It is a couple minutes after midnight in Los Angeles, so I want to say good morning, ladies and gentlemen. It is really a great pleasure for me to be here today. I wanted to first thank for the invitation. I understand that the software industry and system industry in India has not only made your country very prosperous, has also earned the admiration of the whole world. It is really a great pleasure for me to come over here to have a chance to meet all the key players here face to face. For the NESCOM staff, I want to thank their special effort. As a matter of fact, I didn't get my travel visa until the day before my departure, so it was quite a challenge. I'm very pleased to be here today. As an educator, one of the things I enjoy the most is to have a chance to meet very talented young people. Teaching over 30 years in the United States, I have met a lot of very talented Indian students. And this morning we had the youngest keynote speaker, and I was really impressed. And the second thing I'm really very pleased is to meet people who wanted to really do better and who wanted to do better for their fellow citizens. And we have a room for people like this here. And so I'm really looking forward to this opportunity to interact with you. Now, this is a very challenging time. If you recall the opening comment by the chairman of NESCOM, and we talk about this is really a very turbulent time, very uncertain. And this is just one indication that I would suggest you to think about it. Now, can you imagine the largest company in the world is a company that makes gadgets. They don't make cars. They don't make what we eat. They don't make airplanes. They make gadgets. Now, the company actually has one product, and the total sales of that product actually is much more than many, many large international companies. So just look at those data, you can tell the world indeed is very different. And we really have to understand what has happened, what lead us over where we are here today. Therefore, we can really look forward and find the right path to moving forward. So what I'm going to do here today is to present some of my thoughts, and as a token for your discussion. I certainly do not have the mirror in the sky. Like most of you, I don't have the crystal ball in my hands. So when NESCOM asked me, what can we see when we put up a mirror in the sky? And I was really puzzled. When I first received the invitation, and I thought I was going to talk about something related to technological innovation, that would be easy for me. I've been teaching this subject for a long time. But now I'm asked to really tell you about the future. I really don't know the answer. However, as I reflected on my own career, I do have one very fortunate thing that I have a chance to travel around the world. And I've been working for leading university for many years. This gives me a chance to travel to Europe, to Asia. I taught in the United States, I taught in Germany, I taught in South Korea, and I have a chance to meet with many industry leaders as well as talented future engineers. So instead of putting a mirror in the sky to give you a prediction of what will be the future, what I really like to do is to share with you my observation as I travel around the world. And certainly, my observation is more a subjective one. And since I have my own academic background, I work very closely with the industry, but I'm not part of the industry. And so the view I presented to you here may not be shared by everyone, and I look for your input so we can have a discussion. So as a professor, I always wanted to start my presentation by giving you a quiz. So here's the quiz. What's the worst thing you can do when you try to look into the future? Well, the answer actually is very obvious. You don't want to look into the rear mirror. If you try to do that, and you will really confuse yourself. But it's very important to understand where we are here today by looking at how we come up to where we are. So what I'm going to do is I'm going to really give you my perspective in terms of the world we are here today. What's the role of engineering innovation played? And I'm going to address the theme of this conference, which is engineering innovation for a better world. And basically, I have 4 messages to share with you. The first message is, I believe the current innovation model has worked great, but for the few. And it has not really made the world a better place for the many. And I'm going to explain to you what's the reason for that and how we come up with this situation we are in here today. And I believe engineering innovation must adapt a new value proposition. And I'm going to propose to you what's the new value proposition so that we can really work together to make the world better. And as an educator, I also strongly believe that all the change we want to do, we hope to achieve, it must begin from engineering education. I believe that without change of how we educate our future engineer, it is hopeless that we can have a different future of engineering. And I'm going to talk about this change a little bit. At the end, I'm going to show you one example of how this engineering education can be changed so that we can produce engineering leaders that can really do innovation for a better world for the many. So I'm going to first explain what happened. Now, this is really a challenging time ahead of us. And we all heard the news report, and everything started with just a housing bubble, no big deal. Then the next thing happened is a financial crisis. The next thing happened is an economic recession. And now we have something called global depression. And you wonder what will be the headline news tomorrow. Now, someone asked me, what's the difference between a recession and depression? Well, the answer is, if your neighbor loses a job, it's a recession. If you lose your job, it's a depression. So this is really a major concern. Now, there are many economists have analyzed what really happened. What's the consequence of this particular global recession? Will the world be different after one day we finally come out of this recession? Now, there are many different theories, and this is what I saw around the world, and this is what I believe what happened. We understand a very important part of our civilization is the creation, expansion, and maintenance of a very strong middle class. This is true for any society. And middle class is very important for engineering. Why? Because all the engineers we employ from middle class, all the product that we produce, our customers are middle class. So it is very important you understand that all the previous engineering exercise are based on a very important assumption. That is, the middle class is expanding, is doing very well. Now, what happened is that assumption has changed. That assumption has become not true anymore during this economic recession. So what happened is you see the middle class get hit the most. People start to lose their property, they lose their income, and everything's under the water. So what you see is you see the society become divided. And you heard the news about the 1%, the 99% versus the 1%, and you can tell that is a very strong signal. Now, the middle class is being pushed to both sides. Now, what is really important to engineering or to engineer? So we need to understand the middle class is rapidly disappearing in the world. And this is happening particularly true in developing countries. And this is a huge concern of the future of engineering around the whole world. As I said, our employees are middle class, our customers are middle class. If they are suffering, we will suffer. We have to change how we do things. And Earlier, Chairman talked about the inflection point, and we all know what is a strategic inflection point. And basically, as you pass the strategic inflection point, your foundation shifts. Therefore, nothing short of fundamental change will do. And this is another very good case to quote what Albert Einstein has said, that we cannot solve the problem with the same mindset that created the problem. So as the society passed this strategic inflection point, in other words, the rapid disappearance of middle class, we really cannot continue our linear thinking. We cannot keep producing product, increasing the productivity, drive the profit, expand the market. That is not going to be a sustainable strategy for everyone. So let's try to see how we can really have a different thinking so we can really see what is ahead of engineering. Now, before I do that, I wanted to share with you my view of what were we really the problem. I mean, you see the whole problem started, at least in the US, from the housing bubble, right? So it seems like it's not our problem, right? But if you really look at it, actually engineering was part of the problem. I think the first problem is this is a couple years before the financial crisis, we focused too much on something I call non-serviceable innovation. These are the things you innovated, and you push into the market, and you're out of it. You really cannot do anything about it. And the good example is called the financial product. And you understand the financial product, there's a lot of different kind of derivative, very complex, very attractive, and then create all the financial bubble, right? So I want to challenge everybody to think about, is a financial product really qualify to be a product? Now, we often don't ask this question. So product is a product. So we engineer, build a product, and we take it as a product. But you realize that if you buy a Tata car as a product, if it doesn't work, what happens? You go back to talk to him. He has to provide service. Now, suppose I buy a financial product. Tomorrow, the price drops. What I do? Can I go back to the dealer and ask him to serve me? He's not going to do that. So what I do then? So I will talk to my neighbor to convince him this is a good product, and I'll give it to him. And my neighbor wake up, find out, well, this product is not serviceable. So my neighbor will convince his neighbor and the rest of the history. So really, it's very important we as an engineer, we have to really have a very correct, very rigorous definition of what is a product. It has to be serviceable. And later I'm going to give you some example. Another thing I think what happened is because we get drive into these things, do the things right. Engineer's job has always been try to find the optimal solution after 2 decimal points. And we really do not teach or educate our engineer what is the right thing to do. So all our great engineers get hired into Wall Street, and we give them a great title called financial engineer. What is a financial engineer? Okay? I mean, they just take all these mathematical skills and develop some product which nobody understands how it works, which nobody can serve, and they don't know whether that's the right thing to do. And that is really how we were part of the problem. Another way you can see why we were part of the problem is I think we focused too much. For a long, long time, engineer has focused too much on low price competition. The price war is so terrible around the world. As a result, we enter the competition, we blindly compete, no way to stop. So we end up with so many wasteful gadgets. Now, I really want you to pay attention to the phenomenon which I call the gadget generation. There's so many gadgets, which is not really what we need, but we have it. Why? Why not? It's cheap, it's there. So the whole world just driving into that direction. And many of the gadgets are produced globally and through something called global outsourcing. And later on, I'm going to explain to you, I don't believe this model of doing global outsourcing to produce gadgets to satisfy the wants of the few is sustainable. I really don't believe so. Okay? What happened is, if you look at the current crisis in the world, you find out because this outsourcing model, so the developed country and simply take care of the market, and the emerging country take care of the production. So because of price competition, you end up with part of the world overproduce, and the other part of the world overconsume. That is really what really drives the current crisis. If you look at the problem, if you have a society that only produce and don't consume, you have another society which consume and don't produce. It is not a better world for anybody. So, since we talk about this huge waste, and let me give you some example of this e-gadget mess. I mean, look at how many gadgets our young people have. I mean, how many gadgets really take to satisfy them, right? Is this really the right way to do? Is it really ready for this? Okay? So somehow we get this dream of having everybody has the gadgets and everybody consume, everybody just have a good time. But you know what? The gadgets never disappear. They generate huge waste. And you know the worst thing you find out is the gadgets get shipped wrong. You know what's inside this container? Those are all the e-waste. This is not a product. Okay? So your product shipped to developed country, and then you have e-waste shipped backwards to developing country. And this is how we manage the whole world. It's not sustainable. Okay? So, let me give you some quick analysis what I think it caused what happened. And there's a very clear message here. And once you understand the reason behind where we are here today, and you can see how we can correct it and go to where we should be in the future. Let's get down to the root of the problem. The root of the problem actually is a very simple question. That is, what is engineering after all? Now, I've been an engineering professor, and the first thing I would tell my students, engineering is applied science. But I skip the word called natural science. So all the good kids that knows mathematics, no physics, no chemistry, they're engineer, automatic engineer. You know what? I think that's really caused the problem. I really don't think that explains the true mission of engineering, and somehow we forget about our true mission. So I would like to present you another definition of engineering, which I think gives us a very good framework to look at where we have been and where we go next. This is a definition by the late Professor Simon, and we all know he's a great thinker, and he had a book called The Science of Artificial. He basically saying engineering is about a scientific approach and study and application of something called artifact. Now, if you go to dictionary, what is an artifact? Artifact is a man-made thing which has two properties, very important one. Number one, it has to be purposeful. It has to have a purpose. Number two, it has to function. But for some reason, if you look at engineering as applied science, applied natural science, somehow our mind only focusing on function. Want to make things that works. Want to work better, work cheaper. And engineer seems to be hands-off in terms of what's the purpose. Who needs them? Who wants them? We don't touch that part. So you can see a great separation of the purpose versus function according to the definition from Herbert Simon. So I want you to, from the rest of my presentation, I want to use this terminology interchangeably. First, if you look at what is a function, function is really the means of engineering. They are not a goal. Okay? For example, you want to study the physics, you want to optimize your performance, you want to understand the blue reality, and you want to know the technology. Purpose is the end. So you don't want to mix up the means and ends. Okay? Purpose coming from people. You need to understand people's preference, their needs, their wants. You need to understand social reality. And more importantly, you need to understand the market. Now, if you take the definition of engineering is try to produce functional and purposeful artifacts, both this function purpose are the job of engineer. You need to really train your engineer to understand both. So, engineers must understand the supply. For sure, we need to build things that function, and we need to understand the physics. But more importantly, engineer also must understand the demand. And that is the part that has been ignored. Now, after 30 years being an engineering professor, these days, when I give lectures on introduction of engineering, I don't do Newton's law. I don't teach them F equal to ma. I don't teach them Maxwell's law. I don't teach them Laplace transformation. I teach them engineering 101 start from supply and demand. You have to really understand supply and demand to be a good engineer. Now, the things is not that simple. There's even more beyond supply demand. But if you miss the supply, miss the demand, if you're only focusing on the supply, building more technology is not good for the world. So let's look at technology supply versus demand. Now, this is a similar curve that previous speaker used, but I'm going to use it to explain to you a different concept. Now, you look at in the last century, and we have this technology supply and market demand. And certainly, as you can tell, most technology products, once they get onto the market, the price drops. Therefore, you can tell the slope of the supply increase faster than the increase of the demand. Now, this is very easy to explain by the economists. They understand the pricing theory, everything is there. But you see, one thing the engineer like to do, economists don't do, is when we see the line, we try to extrapolate, right? We just draw the line longer. And this is what happened, okay? So this is what happened. You know why economists don't do this? Why economy don't do this? Because nobody studied this kind of economy, right? You got it? They don't study this. They cannot expand this. But this curve was first introduced by Andrew Grove, who was the CEO of Intel. So he said, well, let me try to extrapolate, see what happens. He said, oops, there's something really very important and nobody can explain. It is the strategic inflection point. That now what you see is you have a strategic inflection point, and what happened is after this point, severe price competition begins. And the competition is so severe. It's almost like you're running on the highway, someone bites your tail, and you keep running, and nobody can stop. So even you pass the finishing line, nobody can stop. You cannot simply turn off the light and shut off your factory. You keep running. You keep running into another totally different region where you have oversupply market. Now, once you see this curve, I want you to really look at the gadgets around you. Pull out your smartphone. Do you really need an 8 megapixel camera? Pull out your laptop. Do you really need a 3.2 gigahertz processor? Or why not? I don't need it, but why not? So this kind of thing has been going on every day in our life, and we don't realize what's behind here. So this is a very important lesson. The engineer must understand not only supply and demand, we must understand supply demand in the context of competition, because competition will completely change the relationship between supply and demand. In other words, the very fierce price competition can cause technology supply increase faster than market demand. Again, economists no interest in these things. Engineer is dealing with these things every day. Now, I want to show this thing to you because this gives you the foundation to understand why outsourcing. It is only in the oversupply market you have outsourcing. Okay? So let me explain to you the dilemma of outsourcing because of this competition. So you have market demand. You have a technology supply. So this is high-end technology. And you have a middle-end technology. And you also have a low-end technology. So most of the developing countries now we gradually pick up. So we're in the low end. And you have to understand when you have these things competing, once they cross this demand line, the customer goes this way. So this is really the line that will follow, right? So for the developed country, when they have these things happening, they will quickly outsource to other places in order to still maintain the market position and lower the cost. So this really ends up into a very interesting phenomenon today. That is, you have certain company that are very good in front end. You have certain company that is nothing but in the back end. And this is called globalization. This is called outsourcing. For a while, it seems everybody's happy until the things collapse. Okay? So this is really what happened. The performance matter. So the few companies focusing on these things there, and then you have a severe competition. You pass the strategic inflection point, and then you have price matter. So all the job that we receive as an outsourcing company, like OEM company, those are the jobs which only price matters. Okay? I don't care whether you do hardware, you do software, you do service, you do software. It's all the same. So what happened is, if you really look at, if this is the kind of thing we make our living on, we are really focusing on tail end of S curve. And we all know, if you're focusing on only the price competition of this commoditized service and product, it's not sustainable. It is not sustainable, right? So, this is really what happened. Let me give you an example of what happened in China. We all know the Chinese economy has been doing very well, and they have the largest market because the population is huge. They also have the largest factory. I mean, you can't get a chance to visit some of the factory. I'm sure some of the factory here will be the same. You see millions of people over there. Very impressive. And what happened is, if you look at really what happened in the market of those developing countries, their economic activity in the market is very open. So it has been very market driven on the market side. In other words, whatever customer want to buy, the store will sell those products. No question. You want to buy the best one, you can have it. In the meantime, if you look at what really happened to the factory of those developing countries, even though today in China, say for example, nobody talk about plan economy, but if you look at the factory thinking, the engineering thinking is still very plan economy. The only difference now is the plan does not come from central government, it comes from where? From your brand company, from your quota. So in a way, you have to understand the society really become very awkward because on the market, it's quite open, everything goes. In the factory, you're waiting there for the quota to be given to you. So this is what happened. You'll see a society which is very strange. That is, all the stores are flooded by very expensive foreign product. In the meantime, all the factories are occupied by very cheap foreign products. That is really what happened. And what you have this M-shaped society, and you start to drive to the bottom. And this is what happened, we all know. Now there's a lot of issue related to environmental damage, product safety, and the very important thing is this creates a very difficult social divide. And the social divide, as we talked about the disappearing of middle class, the social divide has really become a major challenge that everyone, including engineers, must face. So I always use a picture to explain what happened in the developing countries through outsourcing. If you visit those countries 20, 30 years ago, this is what you saw. This is what you see today. What happened? It's just indoor farming. Nothing really has happened much. Okay? This is not progress. This is not the better world for everyone. So, what have we learned? Well, there are several important lessons we learned here. That is, engineers really need to understand supply, demand, and need to understand the competition. If you do not understand this, you're focusing on, for example, if you're focusing on the supply, you keep developing technology, keep pushing out the product, okay, for your quota, and you'll find out you end up with a huge waste. And you don't benefit the middle class. On the other hand, if you try to say, okay, let me take care of the supply, I be your OEM, right? You take care of the demand. You know the market demand, right? And you'll find out this is really impossible. I mean, in the ideal world, that should work, right? But the world is not ideal. This is not possible. This is a very difficult balancing act. It's impossible to do. So we end up with part of the world overconsume, part of the world overproduce. And middle class in everywhere start to suffer. So this is my proposal if you look at the future. I think we need to refocusing on a very important part of engineering. Engineers need to understand demand. And we need to really start to ask ourselves, what is the purpose of engineering? What is the demand? We understand the demand has wants and needs, right? And I want you to realize that 1% of people have a huge wants, but 99% of people have a real needs. And you need to really understand the difference between the two. So, we must choose the right demand, the right purpose. We have two choices. One is we can keep stimulating the wants of the few. Keep producing iPhone 6, iPhone 7, iPhone 10. Okay? We expand the market, we increase the profit, and we generate waste. We keep doing that. Or we can satisfy the need of the many. This is a more long-term strategy. This needs a very deep insight of your society and humanity everywhere. And earlier we heard some question about the social entrepreneurship. And I think this is really the same underlying theme. The engineer need to take more social responsibility in order to innovate for a better world. So my thesis is, if we keep stimulating wants without fulfilling the needs, it is not sustainable. We really need to start to focusing on right purpose. So you heard of a word called blue ocean strategy. So what is the blue ocean strategy here? So here again is a demand curve. Okay? And we understand because of the competition, and we have this different layer of company competing on the market, and we understand this is how the market will choose, right? And traditionally, we try to catch up those developed countries, try to do R&D, right? So that's really the R&D approach. And we understand this end up severe competition and end up a price war. Now, this has been really our strategy so far. It's called red ocean strategy, that you keep producing their OEM, and you try to supply them cheaper technology. And this is really the typical, you worry about market, I worry about the production, and everyone will be happy. Doesn't work that way. Okay? So my proposal is, what is the blue ocean strategy for the future engineering? We need to look at this. That is, we really need to look at how we can find out the real demand. I believe the real demand is the need of the many. The need of the many. Instead of simply focusing on the wants of the few. Okay? So, we talk about the needs of the many. Now, this is actually existing everywhere. We just don't realize that. Somehow we don't pay attention to that because those things are not sexy. They don't get on all this news report there. They don't contribute to our bottom line right away. But if you look at it, this is very important. I mean, now, about 2 years ago, United States National Academy of Engineering conduct a very comprehensive survey, and they basically asked all the people in the society, what are the grand challenges of engineering? And this is 2 years ago, but if you look at the result, it is very similar to what I said, the need of the many, not the wants of the few. The first one is environment, energy. The second one is infrastructure, security. There could be a cyber infrastructure, could be real infrastructure, health, medicine. This is the need for everybody, right? And learning, education, need for everybody. Okay? So, if you're interested in this, you can go to the report, very elaborate report, talk about all different need engineers to focusing on. Okay. So, now if you open your eyes to the need of the many, you find there are plentiful. Security issue, healthcare issue, drinking water, food supply, clean air, renewable energy, all different things here. So what I'm preaching to you here is nothing really new. It's just ask your attention to these pyramids. And there's a lot of talk, including some of them I think will be presented here in this conference, called the bottom of the pyramid. And that's the same message. It's called doing more for more, same message. It is very important to do that. And later on I'm going to say, how do you do that? How do you do that? How do you really understand the need of the many? And that is really the big question, because engineers, somehow we understand the physics better than we understand people. If you don't understand people, you don't know their need, and that's why all the engineering education has to change. And some example, empowering the many, say for example, and someone developed this very cheap tube, and people can simply use to drink the water from the river. Very cheap thing. And this is a good example of the need of the many. And you must heard the news that Bill Gates Foundation invested $1 million now develop toilet. This is the need of many. Now, many people need this more than they need iPhone. Okay? So, what can we do about it? I think the first thing is we need to change the value proposition of how we look at innovation. This is the old value proposition. Suppose your boss call in, ask you to justify an innovation project, and you're going to really tell them what's the market return in terms of dollar. You're going to tell them what will be the tech, and your boss is going to ask you, well, how much I have to invest. And this is traditional thinking. It's all profit driven. Okay? I would suggest you to change your equation. Okay? I would suggest you look at the other two factors and look at their combined effect to decide where you focus your innovation. The first one is you have to look at the size of user base. How many people really need this? And the second thing is very important. The simpler, the better. The world has become so complex because we keep driving this better technology. We forgot actually what really people need are very simple, very affordable things to help themselves. Okay? So if you look at the top one, that's what I said, you need to empower the many rather than keep serving the few. Now, if you look at simple, how do you make things simple? Actually, there's a very important concept called self-service. You have them help themselves. And this really requires very creative engineering thinking. How do you provide a solution to many people? They can simply help themselves. If we can do that, if we can put that as our target for innovation, and the world will become a better place. And let me give you some simple solution. I mean, this is how people now are suggesting people in the rural area, how do they build a toilet? And simply put something on top there. You have the natural ventilation. There's no technology required, but it requires a lot of engineering thinking, right? And the people now start talking about how do you really pump water from A to B without energy? And all these things actually, as a teacher, you can tell, this is a great engineering problem. It doesn't require rocket science, doesn't require nanotechnology, so it's not sexy, but these are very important problems. These are the most important problems, okay? So we talk about strategic inflection point. So if we keep innovate to serve the few and serve them very well, the whole engineering profession is going down. There's no question about it. What we need to do is we need to do engineering innovation to empower the many. To empower the many to self-serve themselves. I want you to really think hard of this challenge. Then you'll find out in order to do so, a lot of engineering creativity are needed. This is both in hardware, in software, in systems, in everything we do. Do not believe that only complex solution can drive your bottom line. Do not believe that big problems always require complex technology. No. The world has already been too complex because we've been doing too well in many of the technology. I want you to really go back to the basic to think about how can I provide a solution that people can solve their own problem and many people will be better. To empower the many to self-serve themselves. So what does it need? Well, there are many different things. I believe, as an educator, I believe the most important thing is we need to change engineers' training. We should really make sure engineers understand how 99% of people around the world live their daily life. If you do not understand that, I don't care how much mathematics you know, how much physics, how much chemistry you know, you're not going to be really an engineer that can benefit the world. And we must change engineering education. So far, the engineering education has been too much focusing on content. Instead, we need to really teach engineers to have a contextual understanding. Too much engineering focus, education focus, has been on cross-disciplinary. In addition, we need to have them have a cross-cultural understanding. So they understand each other. And we need to have them have a global understanding. So the key is, so there are many different details I can give it to you, but due to the time, I will pick up one called contextual understanding. What is the context? Why is context important in engineering? So what is context? Okay? So I can ask you, does India, do you have a July 4th in India? What's your question? What's your answer? Do you have a July 4th in India? Yes? No? Yes? True? No? If you say no, you're answering my contextual question. If you say yes, you're answering my content question, right? If I open your calendar, well, this is July 4th, right? That's a content, right? But that's not really what I'm asking, right? If you really know the context of my question, you will answer, say, yes, but it is not on July 4th. Got it? So it is very important, we as educators, we must teach them the context. There's so many engineers walking on the street today, they are very good in content, and they have no knowledge about the context. Therefore, they only know how to do the things right. They do not know what's the right thing to do. Let me give you another very interesting example of what is the context. How is this important to engineering, okay? Can you tell me what is this? Okay. This turns out to be an innovation about 3,000-4,000 years old. And in the old days, the Tibet monk, and they like to pray. And their belief is the more they pray, the more they cite their books, the better next life they will be. And the problem in several thousand years ago is nobody reads. So how do you pray from the book, right? So a very ingenious engineer invented this thing called a praying wheel, right? A big praying wheel, right? They encrypt all the books on the wheel, and then as a prayer, you go to there, you rotate the wheel, and as the wheel starts to rotate against the air, and presumably someone up there will be very pleased. That's the whole idea. Great innovation, right? What's the problem of this? The problem of this is create a traffic jam, right? I mean, so many players want to wait there, everybody will rotate these things. So a couple hundred years ago, another very innovative engineer come out with this solution. It's called production line. Okay? So you basically make it a little bit smaller, you put them the whole line, and you put them outside the temple, and you go into there, you just go production line, right? A couple hundred years ago makes a lot of sense, right? Okay? Now, this thing started standardized and everything goes, right? So the next thing happened is standardization happened, right? So the whole thing will have standardization. And the next thing happened is miniaturization, right? So the next thing happens is everybody will have 5 of them, right? So you have customization. No, I'm not joking. This is exactly what happened to our product today, the gadget. Okay? So here's the true story. So a few years ago, an American engineer went to Tibet. And he said, oh my God, this is a huge market. Look at how many of these small gadgets everybody has. This is a huge market. If I can do something to make these things better, I'm pretty sure I will be rich. So he come back, and this is what he produced. Anybody seen this? What is it? I'm sorry? Good. This is an automatic crane wheel, and it is solar powered. Now, you can imagine this engineer spent a lot of time trying to calculate the solar efficiency and try to optimize the spinning speed, everything. So he was very hopeful. As a matter of fact, I got a piece of this. My friend gave it to me. And living in California, I put it outside the window there. And every morning when I wake up, the sun come out, this thing just turned like a crazy. You know what? After a few days, I started to get scared. I wasn't sure someone up there will be happy. Because you know what? Who is praying for whom? Now, this is a very important example of missing what? Missing what? Missing the context. If you miss the context, you will do a lot of good things, but it's so stupid. And this is happening in engineering every day. Missing the context, missing the understanding of your true customer, missing the true understanding of their needs. That is really a very important part what's been missing in engineering education today. So, I want to really take the last 5 minutes to give you a very quick rundown of a major initiative that we're doing. Actually, the initiative involved a leading institution in India, IIT Bombay is a partner of these things. And I'm going to give you a quick rundown of this initiative. This initiative is called iPodia. And we're creating a global consortium of leading universities to enable our engineering students, to learn the global context and learn locally. You learn the global context right from your campus. Okay? And this program is, I stands for international, because we have now we have 7 members around the whole world, and students walk into the iPodia classroom on their own campus, and they will immediately joined by their classmate on the wall. They can talk to each other, and they learn together. Okay? So this is interactive, and this is something very different from the current emphasis on distance education, which we call no distance education. If you really look at it, distance education is a oxymoron, right? Because if you have a distance, how do you learn? I mean, you really have to focus on no distance education. So instead of using IT to enlarge the distance between me and you, and we try to use IT to eliminate the distance between you and you. To eliminate that distance so you can interact. You can interact without the constraint of the border, institutional border, and cultural border right on your own campus. Okay? The next one is innovative. So what we do now is we provide students the material so they will do the study at home. We don't give them lecture. Okay? And this is called flipping the classroom. Because in a typical classroom, we go in there, we give lectures, and students go home, do the homework together, right? Now we want to flip that. We want a student to watch my lecture, because my lecture can be recorded anywhere, right? They watch the lecture before they come over here, and when they come there, they join the world classroom to have discussion, work on project with their classmates. So this is called flipping the classroom. And this is 3 beliefs behind this international effort. Number 1, we believe what you learn depends on with whom you learn. This is very true if you think about it. Most critical engineering disciplines today are social technical disciplines. They are not purely technical disciplines. When you have a social technical discipline, really a lot of things you learn from your classmates. What you learn depends on with whom you learn. Number 2, if you have a chance to learn with people who are very different from you, you learn more. Right? That's why we all benefit when we travel around the world to different places. Somehow our mind gets very creative. Why? Because, gee, those diversity really stimulate your creative thinking, right? And we also believe that learning together leads to a better world tomorrow. It's so interesting that these things we wrote it down a few years ago now. I look at this conference theme called Innovation for a Better World. It's really true. And we believe to achieve a better world, let's have our young people learn together. If they learn together today, they will have a better world tomorrow. Okay? So this is the typical classroom, and you have a big screen in the front, and you have people can talk to each other there, and this is all synchronized. This is not distance education. Okay? And this is how we conduct it. You can tell this is actually last year we were able to run it from Los Angeles. Then there's a site in Beijing, the site in Taipei. I mean, you can imagine the Chinese student, Taiwanese student, they actually learn together while they still aiming missile at each other. I mean, this is really a new generation. You have to look at it. Once the young people are able to become classmates, the world becomes a better place. Okay. Let me show you I do have time for maybe 5-minute video. Okay. Let me show you a video to see how these things work. Okay. The brilliant idea is to open the classroom from any university for them to join together so that students can engage in peer-to-peer learning as a way to inspire global innovation. As people start to exchange those value information, and you can start to collect value, right? Yes? There's something here?
Oh, I was just going to say the same kind of premise
see the student different side of classroom or joint discussion
like that.
Yes.
Where, if you solve ever so many problems and everyone else ensures it is correct, they'll give you access to other correct.
Now, any suggestion from PKU, NTU side? So I threw the discussion into Beijing.
Yeah, there are many successful cases, but I still doubt. Why should I share my information to others? It didn't make any sense to me.
Actually, you see, this kind of information sharing is such that for each individual, the effort is nothing. But collectively, that seems to become very valuable. Any questions? Yes, go ahead.
Still, I have a question is, like Wikipedia. It is true that I did my little job and I get much. But even if I didn't do anything, I can still get the information, right?
You have answer?
The reason why I personally contribute to Wikipedia is because we all have certain areas of knowledge that are expert areas of knowledge, and in sharing that with others, I mean, I gain a certain satisfaction. And like you said, the biggest satisfaction comes from being like, oh,
I know better.
Wrong.
Yeah, I know better.
I'm more intelligent than random internet guys.
Exactly. Any input from NTU campus?
I think it's always, to some extent, depends on the convenience to the access. Like the Facebook, actually, I didn't get anything from the Facebook, but it's easy to access. And the Wikipedia, I didn't need to do a lot of things to get to provide more information there. And it is a fashion as well.
Okay, let me just comment on what the example you see. You see, just one question, you will generate very different contextual response from students from different culture. The question was, why would you participate in Wikipedia? Nobody pays you, right? The American students say, well, because it's fun. Because it's good, it's fun, I'll do it. The Chinese students say, well, if I can use it free, I will use it. I'm not going to contribute it. Okay? And the Taiwanese student will say, if it's good for me, and if it's better than what I put it in, I'll do it. You know what? There's a huge value difference. A good engineer to understand this. If you want to be global, your engineering thinking has to be global. You need to understand what people need, what people think in their mind. And then you become a good software engineer, good hardware engineer. Okay? So let me quickly run through these things, and then we will finish. And we are now expanding to South Korea. Now we have 4 sites. The live audience here in the middle of South Korea Peninsula. We have 20 students located in Los Angeles. Here in this screen, and what you see is the 20 students from Peking University in Beijing, China. What you see here is, well, for the time consideration, let me stop the video here. And I will, if you are interested in these things, I can provide you certainly much more detail later on. Okay, so let me go back to my presentation. And right now we have 7 universities. And as I said, IIT Bombay is our partner. And we have university in South Korea. So for example, when we teach courses with KAIST in South Korea, and they will invite Samsung engineer come in. And when we teach in California, we invite Apple engineer come in. And engineer students all come talk about the product development. And while Apple and Samsung are fighting each other on the core, they are actually discussing all the good ideas in the classroom. So classroom is a very important place for people to really get to know each other, become a better world. Okay? And we have people in Beijing. We have a Technion from Haifa, Israel. And we have Aachen in Germany. And we have a USC here. And we are in the process including a big university in South America. And we are including someone from Middle East. So now you can tell Israelis and Middle Eastern people can learn together. And then we can have someone from Africa. So this is really going very strong, and people want to join to create a classroom without border. Now, the relevance to us all sit here, unless you're interested in go back to school to learn. It's, if you have future engineers who can be educated in this way, they become an engineer that have a much better contextual understanding about the global world. And we will not then make the same mistake as we did in the last century. So here's my summary remarks. And I have run through this very quickly to explain to you what happened, what caused it to happen, and what have we learned, and how can we do about it. And really what happened is we have already passed strategic inflection point. And there's no doubt about it. You really cannot do business as usual because the middle class is shifting, is changing, new thinking must come in. And what it caused happen is actually something very fundamental, but we somehow ignore it. We somehow lost sight of the true essence of engineering. Engineering is not about applied physics. Engineering is about understanding the supply-demand under competition. And that is a very important part that we need to bring back. What have we learned? We need to have a new value proposition for engineering innovation. Rather than all this investment and return, we need to look at how many people we serve, how simple is my creative solution. And finally, I believe if we can change the education, and we'll have a hope to change the future. Otherwise, all these things are academic talk. So I want to thank you for your invitation, and it is really a very, very rewarding experience for me, and to come over here. And I always believe learning together for a better world. Now I know if we learn together, we can do engineering innovation better for a better world, and that's really very rewarding. And I want to thank you for your attention, and feel free to contact me if you have any questions. Thank you very much. Yes, please. I'll be very happy to. Yes.
Professor, thank you very much for a very thought-provoking presentation, and very happy to see something coming from academic that's actually going to influence the society at large.
Thank you.
My question is that the whole world is moving, both the developed world is already there, the developing world is moving towards capitalistic economy, but what you're talking about is the social re-engineering. So how do you expect the gap between your thought and what's happening in the real society to influence and change?
You know, I think the change has to happen ourselves. I think you cannot expect others to come to change you. I think particularly for the developing country, we need to take responsibility of our own future engineer. We need to take responsibility of our own demand. That we look for somewhere else have a solution. We send our engineer to other places for training, and then we come over here simply take our OEM quota order. I don't think that seems to work anymore. You are the best person to understand the need of your own people. You must train your engineer to do that. What I'm really talking about actually is a very simple concept. We must bring humanity back to engineering. And humanity, I don't care how the things are global, humanity is always local. It is very important to focus on our own thing. We also have to bring back the fundamental challenge of engineering. It is not to create a complex gadget. It is to create simple solution. The simpler solution require higher degree of creativity. And all these things have to come from our own.
Thank you.
Yes?
Good afternoon, sir. I myself am
I cannot
Hello.
hear you.
Yeah, good afternoon, sir. I myself am a final engineer student, and I was very overwhelmed by your presentation. But the thing I want to ask you is, you say that thinking global. So how does an engineer comes to know then when he is thinking globally? And as means how to understand means as a person myself, I have to understand my needs, or I have to keep myself in someone other footsteps. And being global means that's emphasis. Can you tell me more about it?
Okay. I'm not sure I quite catch your question, but let me try. Okay. I think if you want to really do globalization, the first thing you have to globalize is the thinking of your people. That's number one. I don't care how you globalize your business. If your people's thinking, if your education, if your young people are not global, it's not working. Okay? So far, since we have not done that right, and we globalize the business, and yet the rest of the society, our thinking are still very local, so we don't really see how we can train engineers to be global. But I tell you, once you put engineer into this global platform, I mean, we have done this iPodia learning for 3 years already, and we can tell students really come out to be very different. Not only now they learn the content of the subject better, they develop much more contextual understanding of global issue. And more importantly, they develop mutual understanding of each other. All these things are relatively soft in a traditional engineering point of view, But I really suggest that we don't look at these things from traditional viewpoint anymore. That's what I said earlier. You really cannot solve your problem by the same mindset that created the problem. So do not take a traditional view of engineering and how engineer can be global, what's soft, what's hard. Try to take a fresh look. Okay?
Question is, demand is being...
I'm sorry. Yeah, please.
Yeah, I'm Jyotirmoy. What I had wanted to ask you is, what we see is that demand is being created artificially by something called marketing. And engineers are now trying to become, join the marketing as a profession to create the temptation in people to create that artificial demand. How to overcome that, which is, which is often the cause of finally,
I'm not a marketing professor, I don't know. But you are quite right to point out that a lot of demand today are created artificially for profit. And we should really not do that. And the sad thing is because engineers never understood the true demand. Therefore, we blindly led into fulfilling this demand. We blindly follow this wrong path. I think if we all wake up, try to really learn the ability to understand the demand of the people around you. I mean, this is not a big rocket science. You don't need to really understand too far. You just understand the people's need in your own village. And try to do that. And you will find out a lot of things you can do right away with a very simple solution as an engineer. You will really feel much better about yourself as an engineer. So I don't think the market should really give you an illusion. If you truly put your eyes, put your heart back to yourself, back to the people around you, and then you will be able to see the demand much clearly. And certainly if I talk to the marketing professor, they will disagree. And that's really, I think, the sad thing. I think engineers need to bring these things back to us. We are good engineers. We can produce things functional. We also must participate in deciding on purpose. We must have that right back.
This is an observation and from the Indian context. As a mother of a young engineer as well as somebody who got educated in IIT, and since you're collaborating with IIT, I see there's a lot of gap in terms of what young people in India want to do. Because we are talking about thinking globally or bringing the global culture home, looking at your surroundings and providing solutions. But my view here is that, is there really an excitement in engineering in our young people?
I'm sorry, the last word I did.
Is there excitement for young people to become engineers? Because that's where I see a gap. If I see the number of students going to IIT and how many of them really pursuing engineering careers today, it's a very dismal amount.
I didn't quite catch you. What engineer did I?
So if I look at 100 students going to IIT,
right,
and how many of them becoming engineers and really working in engineering careers, you would see only 20% of the population becoming engineers. The rest 80 are looking at financial careers. So I think that from a perspective of India, it's extremely important that apart from whatever we are doing in terms of bringing the engineering context, it's important to start even before you go into an engineering college to really create an excitement in really becoming engineers.
I cannot agree with you more. I think this is a very right-on comment. And that's why one of my efforts right now is to provide such global learning platform to younger people. As a matter of fact, we're working with the association now, want to provide the globally networked kindergarten. Now imagine you started to have this kind of learning environment when you are in kindergarten. You grow up, become a very different people. By the time you're in college, it's very different. Now, I fully agree with you. There's a lot of things going wrong, which is not right in engineering. Engineering somehow become not sexy anymore. People all want to go to financial things. I think we did that to ourselves. I really think we did that to ourselves. I think if we started to really have the ability to observe people, to have the ability to really see the true need of the people around us, we will become a very exciting field again. Yes?
Hello. Yes, Professor, if I may, I just wanted to link that point and your earlier points with the gentleman at the back of the room about globalization. I'm involved in a business that's helping to train engineers to become globally effective managers. And I think the big thing that we've seen over the last 18 months here is that engineers, this country is full of very, very good technical guys, but they're generally coming out of an education system that does not give them, it doesn't help them to become particularly self-aware. And self-awareness is the crucial thing generally that's missing. And until, and the number one thing we say to our teams say to these guys is read widely. And the story after story after story comes back that when they start to read widely and get a better global context, this then helps in their global communications and their operational effectiveness. Time and time again. So I would just endorse that.
Very true.
Absolutely, and think that it's really all down to self-awareness and spreading the eyes beyond the textbook to the world in which we're working in. Anyway, thank you.
Very true. I fully endorse your point about self-awareness. This is a global world. We need to teach our engineers to be truly self-aware in the global context. That will make them not only a better engineer, a better person. And that will make them cool again. Thank you.